questions from the assignments? You guys, we did long division and synthetic division. Any questions? What were the problems? 6 through 33 by 3s. So like 9 problems is what I assigned. Should I do a few? Okay. Let's do using long division. So let's do 7. It's not one of the ones that's a multiple of 3, but it's an interesting one by observation. You guys want to do this? You're trying to find maximums and minimums. It's calculus. Kind of fun. Some of you will take calculus at some point. It's not that hard. Like this, all you have to do is multiply 4 times 3 and get 12, and divide it by 2 and get 6. And subtract 1 from 4. 4 minus 1 is 3. That's all you do. So 3 times 4 is 12. Subtract 1 from 3 and get 2. 2 times 9 is 18. Subtract 1 from 2, you get 1. It's not that hard. And then you set it equal to 0 and factor it. Find the zeros of the first derivative. And those are the spots on the curve where there's minimums and maximums, like del tops and del bottoms, which we've already talked about. Like the maximum value of a function. But these are functions with higher degrees than just 2. So higher degrees than just a parabola. So this is what we have to do. Abigail, what do you know about it? Nothing. Okay. I knew you weren't here, that's why I was asking. So we're going to do long division. We're going to divide this dividend by this divisor. Now, you have to make sure all the powers of x are represented. So if it starts with x to the third, then you need a placeholder or an actual term with an x squared. You need a placeholder or an actual term with an x, and a placeholder or an actual term with, a term without any x's. Like for the thing we're dividing by is x squared. It starts with x squared, but there's no x term, so you have to put 1 in, plus 0x minus 1. And we're going to do this long division with that. Okay? I know you can do this, because you did them while I was teaching yesterday. But I'll get somebody at random to do it. And if it's you, I'll help you a lot. Do you want to do it, or choose a number between 1 and 10?
I'll choose a number. 6.
6? 1, 2, 3, 4, 5, 6. Tail.
Okay.
You'll be good at it. You,
Yeah.
yeah, you were doing it yesterday. You were well. So what do I do first?
You have to multiply by x.
Yeah, x squared times x is x to the third. So you look at these two things. What do you multiply this by to get this? And that's x. So you put an x in the x column, right? X times x squared is x to the third. X times 0x is 0x squared. And x times -1 is -1x. Now what?
You subtract.
Good. The way you do that is you change the signs. So that's negative, this is negative, and this is positive. And then add. Change the signs and add. Okay? Those add to 0, this adds to x squared. This adds to 2x. And then we need 3 terms, because this is 3 terms. And we drop down this plus 2. Okay? Now what?
And then you have to multiply by 1.
Yeah, x squared times 1 is x squared. So you put a plus 1 there. 1 times x squared is x squared. 1 times 0x is 0x. And 1 times negative 1 is negative 1. And then what?
And then you, it's gonna be 2x. And then you have to subtract.
Great. Okay, so change the signs and add. Negative there. That's negative. This is positive. What do you get when you subtract?
Plus 3.
Perfect.
And
So
then-
this is the remainder, right? So since we're already at the end, so you add a fraction. What's the fraction?
You're gonna put 2x plus 3.
On the top, 2x plus 3. And on the bottom,
2x squared minus 1. Or minus 8.
what you're dividing by, x squared minus 1. And that is the answer. Long division. Okay? Any questions? Thank you. Nice job. Um, so let's do another one, maybe? Yeah? We'll do 9, because 9 looks like it's got a bunch of stuff. No. 5x to the 4th minus 2x to the 3rd minus 7x squared. What's the next term? 0x. We need every power of x accounted for. Minus 39. We're going to divide it by x squared plus 2x minus 4. Okay. What first?
Multiply by 5x squared.
Yeah. You look here, what do you multiply x squared by to get 5x to the 4th? And that's 5x squared. 5x squared times x squared, 5x to the 4th. 5x squared times 2x and x to the 3rd. 5x squared times negative 4, negative 20x squared. Now what? Change the signs and add. Negative here, negative there, positive here. So these will always add to 0. These you get negative 12x to the 3rd. Plus 13x squared. And what? Drop down this plus 0x. Okay? Now what? You look at this, you look at this. What do you multiply this by to get that? Negative 12x. So minus 12x. Negative 12x times x squared. Negative 12x to the 3rd. 12x times positive 2x, negative 24x squared. Negative 12x times negative 4, positive 48x. I think that's right. Now what?
Change the sign there.
Change the signs again. Positive there, negative there. Goes add to 0. This is 37x squared. And this is negative 48x minus 39. X squared times 37 is 37x squared. So plus 37. 37 times x squared, 37x squared. 37 times 2x, 74x. 37 times negative 4, 148. No, I did 74. Yeah, I think I'm right. Because this is 2 times 37, right? So all you have to do is double this. 148? Yeah, 148. Minus 148. Now what?
Change the sign there.
Change the sign. Goes at 0. This is negative 1, 2, 2. That's right, x plus 19, 119.
I think it's 109.
Is it 109? 40, 108, thank you. 108. Now what?
You have fraction.
We're adding a fraction.
So the negative 1 times 2x is 109 over x squared plus 2x times 1.
Good. Okay, everybody good with that? Any questions? That is long division. And we also have to do some synthetic division. And we can do 5 and 6 using synthetic division because it's just a binomial with no coefficient in front of x. Can't do 7 or 8 or 9 or 10 using synthetic division. And all of these you can. Anybody want to see one in particular? It's nice to do the ones where it skips powers of x. Like 14 or 15, 16, not 17, 18, all of those. But let's do a simple one, right, so you can see how to go. So we'll do 13, and we'll go to 14. Okay. Who else was gone yesterday about 13? No, just the other one. So synthetic division it's set up a little differently. We're gonna have a line of numbers here, a line of numbers here, and a line of numbers here. This is like 3 rows of numbers, okay? Number goes in the box, it's the value of x that makes that 0. What number makes x plus 5 0? 0 plus 5 is 5. Okay. And the coefficients, instead of number, or instead of variables, we just put the coefficients down. So 2, -1, and 7. That's it. Okay? So we're going to have row numbers here, and row numbers here. And this is going to be the answer. This 2 always drops all the way down. Okay? And then whatever number's down here, you multiply up here and put it in the next spot. So 2 times -5 is -10. And you add these. Multiply, put it in the next spot. And add these. And this is the answer. All we have to do is apply x's to it. Since we started with x to the 2nd power here, we're dividing it by x to the 1st power, like x to the 2nd power divided by x to the 1st power, you get x to the 1st power. So in your answer row, this is 2x minus 11, and that's the remainder, plus 62 over x plus 5. That's what you get when you apply the x's to the answer. The mistake most people will make is they'll put x squared here, and then put an x there, and then they won't have a remainder. And that's how you screw it up. Okay? I thought I took a picture for it too.
-3 in the box. And then 1, -0.
0, the placeholder for x squared. Okay?
And then -4 will be 6.
Leave a good amount of space so you don't get messed up with each one of your columns.
Then 1 drops down.
1 drops down.
And then it's 1 times -3 is -3. -3 goes down. And then -3 times -3 is 9. 5 goes down there. And then 5 times -3 is -15. That's -9 over x plus 3.
Okay, so let's write the answer.
1x to the 3rd.
It starts with x to the 3rd.
Also it's 1x to the 2nd. And then it's -3x plus 5 minus 9 over x plus 3.
Or you can say plus -9 over x plus 3. Either way. Any questions? Can you guys do these? Was there anything else? Any questions besides those? Do you have questions from the You guys know how these work? I have one on the test. Use synthetic division. They give you a number. I'm looking for one they skip. Yeah, this one. 6, it's, could be a pain. Okay? So this is, it says evaluate the function at the given value of x using synthetic division, right? So our answer, we're going to be looking for x of f of 6 is whatever number is the answer. So we're going to use synthetic division. And whatever we get for the remainder, that's the number that goes there. And what number is in the box? Remember, this is different. Because before we were looking for the value of x that makes it 0. But this time they give you a value of x to use. So don't change the sign. Use that value of x.
6.
Yep, 6 goes in the box. And then what about the coefficients out here? 1.
0.
Nice job. You need a placeholder for the x squared.
-6.
And 1. Good job.
Drop
1 drops down.
6.
1 times 6 is 6. Add these together. 6 times 6.
36. 30.
30 times 6.
180.
Nice job. That's it. Perfect. Whatever the remainder is, that's what you would get if you actually put 6 in. And you could do that, like 6 cubed is 216, subtract 36, 180 plus 1, 181. I did it. Okay? That's everything we learned yesterday. I think that's a lot. Okay, any questions? Okay, so we have stuff to learn today. So the assignment tonight is some of these and then some from the next section. I'm going to teach you the next section. 4.4, factoring polynomials. And this is not a lie. There is a section where you have to factor them. And remember the first 2 weeks of the school year, all we did was factor? It's pretty much the same stuff. So it's kind of a review of the factoring we've already done. So if you can factor, this should be a great section for you. Okay? We good? Factoring polynomials. We're going to do some things with the factoring. Math. Can you factor how can you factor? So look at it. This is really important. Like how do you match these up? Like the first one we could factor, right? Are there 2 numbers that you know that multiply to 4 and add to 5? You know they're both pluses. Why did I put a 1 there? No idea. What are 2 numbers that multiply to 4, add to 5? 4 and 1. So if the factors are positive 4 and positive 1, x plus 4 and x plus 1, what are the zeros? What values of x make it 0? -4, -1. So we're looking at the graphs, which one cross the x-axis at -4, -1. C. So this one is C. Got it? Like this problem, we can factor an x out. And then and this factors, are there two numbers that multiply to 2 and subtract to 1? Yeah, x minus 2, x plus 1. The zeros are 0, positive 2, and negative 1. 0, positive 2, and negative 1. I don't see it. You're wrong. Got it. That's why it's not there. It's 0 plus 2 minus 1. So 0, negative 2, and positive 1. 0, negative 2, positive 1. Looks like it's E. C, Z. Even this one factors. Because x squared times x squared is x to the 4th. The numbers that multiply to 4 and add to 5 are 4 and 1. And this factors. It factors into x minus 2 and x plus 2. This factors. It factors into x minus 1 and x plus 1. So what are the zeros? Positive 2, negative 2, positive 1, negative 1. Which one has all of those zeros? Negative 2, negative 1, positive 1, positive 2. So D goes with E. Okay? Factor it, and the zeros of the factors are where the graph of the function crosses the x-axis. I mean, I'm losing some people. What was for lunch? It must have been awesome. Who's sleeping right now? You're sleeping. You're sleeping. Check him out. His eyes are like almost shut. What was lunch today? It must have been delicious, like pizza or something. What did you have? You didn't eat lunch? You need some food. What did you have for lunch? It must have been like loaded baked potatoes or something like that today. That's what it always puts everybody to sleep.
It was like mini corn dogs.
Oh man, that sounds good. Did you have mini corn dogs?
Yeah, they give only 6.
You only got 6? So if you had 7, you'd be all ready to go. Okay, so going on to the next thing. Factor each polynomial completely. You guys want to try this? See if you can do it?
Yes.
It's kind of fun to do.
Oh, yeah.
Nothing like doing a little math to wake you right up.
Who said that?
Problem is, nice warm room. It's just so comfortable. Just so cozy, sitting there.
You know how to do it.
So I'm kind of going to assume you guys can factor. Now you know that to look for common factors to start this problem off, right? Each one of these you look for the common factors. We'll call on somebody at random and see if you guys just come out with a factor. Ooh. Try to be extra energetic because my goal, my fitness goal for this month. Because I have 14 days ready. Right, I have 200% of my new goal. And with 6 days left, I needed 6 more. Like, man, it's slacking this month. So I'm trying to. It's amazing. Okay. Ooh. James, Maddie, Isaac's already gone. Amelia. James, what can I take out of all three?
You can take out an x.
X comes out, what's left?
X2 minus 4x minus 5.
Does that factor
Yeah.
into what?
Minus 5 and plus 1.
Minus 5 plus 1. Let me just point something out to you guys. If it said y equals, like what does the right side of this polynomial do? James, that's you. What's the right side of the polynomial do? Does it go up or down?
Oh, it goes up.
Yeah, because why?
Because x3 is the greatest power.
It's positive, right? And then what's the left side do?
It's going to go down
How do you know?
because it's an odd power.
Odd power. The right side goes up because it's positive. So I could graph this right now, because I know the zeros of the polynomial are 0, -5, and let's try that again. 0, +5, and -1. I know the right side goes up and the left side goes down. So if you connect all those points with a smooth curve, that's what it looks like. That's something you guys have to do on some tests. You get a polynomial that looks like this, you graph it, you factor it, find the zeros in the polynomial, and then you look at the leading term, notice it's positive, that means the right side goes up. Notice the power is odd, that means the left side goes down, and it's going to go through these points with a smooth curve. That's what we're doing soon. Who's the next person? Amelia's third. Maddie, what the heck, are you hiding from me? What can you take out of both of these?
3 and 1
One of the third. What's left?
squared minus 12, no, 16.
Okay, so 3 y to the third. How does this factor?
And 8 minus 8 plus 8.
8 times 8, 64.
No, sorry. 4.
Minus 4 plus 4. Exactly right. Amelia? What can I take out of all three of these?
5z squared.
5z squared. What's left after I take 5z squared out?
Z squared plus 6z plus 4.
Does that factor? What's it factor into?
Z plus 3 and z plus 3.
Good. Which you can write as 5z squared times z plus 3 squared. Now, this thing factors neat, in a neat way, because the multiplicity of the 0, that's -3, right? Because -3 is the value of x that makes this 0, is 2. That means it doesn't cross the x-axis at x equals, or z equals -3. It just touches the axis. So if we're graphing this, and those are x's, not z's. If we're graphing this, the zeros are at 0 and -3. I know because the leading term is positive, the right side goes up, and the leading term is even, the left side goes up as well. How, whoa. But since the multiplicity on both of these zeros is 2, an even number, it does not go through the x-axis. So it does this. Touches the x-axis at one point, goes back up. Touches the x-axis at one point, goes back up. And that's what it looks like. All right, let's do these three. Factor these three completely. You guys remember factoring? Is this going okay? Angela, you should dominate the factoring section. Move to Abigail is not going there. James, Joanna, Alfonso, Macklin, Brett, Nora. What else did everybody get to go? I need 3. Macklin. Brett. Ready? Is there anything I can factor out of all 3 of those? X comes out. What's left? Good. Does that factor? Great. Macklin. And to the 5th. What's left? Is that factor n squared minus 25? Good. Brett. 8 n to the 3rd. What's left? One. Good job. Yay. Are there 2 numbers that multiply to 1 and add to 2? What are the signs in here? Yes, they are. Nice job. You guys good? Ready to factor? It's not going to be the whole test, it'll just be half of the test. Could be your best test ever. That's what I'm saying. Sums of cubes, difference of cubes, you guys remember doing those? Those are fun. I know. If it's a sum of cubes, the trick is you have to figure out what's cubed to get 64x to the 3rd, and then it's 4x. It's 4x, and it's 4x, and it's 4x. It's 64x to the cube. When it's cubed, so you get 1. Well, 1 is cubed, you get 1. 1 times 1 times 1 is 1, obviously. And then you factor. It's a binomial and a trinomial every time. And the signs, same, opposite, always positive. So the only thing you have to remember is whatever is cubed, 4x, goes here. Whatever is cubed, 1 goes there. And And then if you could square each one of those, 4x times 4x is 16x squared, that goes here. 1 times 1 is 1, that goes there. And then you multiply them together. 4x times 1, that's 4x, that goes in the middle. And that's our factor. It's really not that bad. And if it's a difference of cubes, it's the same, opposite, always positive. So, same, opposite, always positive. Same, opposite, always positive. Like, here I have the perfect cubes all listed right here. So if it's a difference of cubes or sum of the cubes, it's going to be these numbers. It'd be fun to use 11 times 11 times 11, 1331, because that's kind of like the Pascal triangle numbers. I really don't have time to do what I'm doing. All right, we'll have to wait till tomorrow. You guys know what the assignment is, right? It is this. Page 177, 7 through 31 by 3s. I think we did 7 already. So that's only like 9, 8 problems now. And then 5 through 15 odd. So that's like 5. Okay, on the next section.